Hello. Today we are going to be looking at second order non-homogeneous equation. Actually, a particular method called the method of undetermined coefficient. There are actually two methods that can be used to resolve second order non-homogeneous equation. We have this one we want to look at now, which is the method of undetermined coefficient. Then secondly, we also have the method of variable variation of parameters. Okay. Now, but here we are going to focus on this. Okay, so by definition, a second order non-homogeneous equation is such that the squared y over dx squared plus 2a dy dx plus by equal to rx. Okay, now remember that this equation, this is how you write a second order non-homogeneous equation, but this is exactly the second order homogeneous equation, which is equal to 0. If you missed my class on that, you can check, ask me for the videos and I send them to you. Okay, so um we have this, and it has two solutions. There are two solutions for a second order, that's using the this method. Now the first is the general solution, which is the squared y over dx squared plus 2a dy dx plus by equal to 0. That's the general solution, which is gotten by solving the operator as a quadratic equation. Then we also have a particular solution, yp. That means you look for a particular value of yp such that when you substitute it into this, it is going to be equal to rx. Then after that, you see that the final solution is a combination of the two solutions. That means a combination of this general solution and the particular solution. Okay, so this is how to determine the particular solution. Remember, we already know for the general solution, which is to solve quadratically. Now is the particular solution. So you can see Rx here and Yp. Now, when Rx is a constant, your Y is a constant too. Your particular Y is a constant. When Rx is a exponential bx, your yp is a exponential. Remember, the a there is actually a constant, both the a naught and the a. Okay, so when you have a cos ct or a sin ct or a combination, the yp will be this: a cos ct x plus b sin cx. Then when you have a power function, this will now become a particular solution. Now, the various examples we are going to be seeing will make us understand this perfectly. So don't worry if you don't understand it yet. Now, but you should note here that this method only applies if Rx is one of the above. So you cannot use it to solve range of values of method except, one of the above values are Rx. So we see a question here. It says use the method of undetermined coefficient to solve the equation y prime prime plus y prime minus 2y equal to 2x. Now, just like we said, we start with finding the general solution. Okay, so my general solution here, the characteristic equation is supposed to be r squared for y prime prime plus r for y prime, then minus 2, all equal to 0. That's the general solution. Okay, so equal to 0 makes it the general solution. Now let's see, are there values we can use here to factorize this? Now should be r plus 2 and r minus 1 equal to 0. Okay, because 2 times minus 1 is minus 2, 2 minus 1 is 1. Okay, so that works. So meaning that our r is equal to minus 2 and our r equal to 1. Okay, so that means my yh, we represent the general solution, is equal to, according to our formula, should be c1 exponential r1x plus c2 exponential r2x. Okay, with this now it means so my c1 is a constant. C1 exponential r1 is minus 2, so minus 2x plus c2, which is a constant, exponential r2x. Your r2 is 1, so that means just x. That is exactly what we have. So that is the value for the general solution. You can go somewhere and write that down, that YH is equal to C1 exponential minus 2x plus C2 exponential x. Okay, so now the next thing is to find a particular solution. Remember, we are seeing this as R1, R2. It doesn't matter which is R1 and which is R2. Okay, so now the next is the particular solution. How do we go about the particular solution? Now, since your your Rx is equal to 2x, okay, it means that my y, the particular solution yp, is going to be equal to ax plus b, you know. Now, assuming it was 2x squared, assuming your Rx was 2x squared, it means that your yp now is going to be ax squared plus bx plus c, and so on and so forth. Okay, the same thing when it is cube, and so on and so forth. So that is how to go about that. So let me rub here off quickly. Yeah, so we continue with what we are doing. So if yp is equal to ax plus b, then we can find y prime p. What is y prime p? Y prime p is, to differentiate this will give us a, okay? Then we can find y prime prime p. Differentiate a is going to give us 0. So we can substitute that into this equation. Remember, we had that y prime prime plus y prime minus 2y is equal to 2x. If we make that substitution, y prime prime p here is 0, as we can see, okay, plus your y prime is a, so we have a, okay, minus 2y, that means 2 times, what is our y? Ax plus b, okay, all of this is equal to 2x, okay, your Rx 2x. So if we open up the bracket, we are going to get a minus 2ax minus 2b equal to 2x. Collecting like terms now, we are going to have a minus 2b, okay, minus 2ax equal to 2x. Now at this point, we can find a and b. Very simple, just by comparing the constants, or comparing the left hand side, both sides of the equation, you know. And if we do that, permit me to rub this other side off here. So we rub here off right now, and we continue. Okay, so this is good. And comparing both sides, you can see that in the left hand side, the one without coefficients is a minus 2b. That means the one without x, sorry, a minus 2b. On the right hand side, there is no x, so that is 0. That means the coefficient, the constant coefficient. On the left hand side, the constant coefficient is a minus 2b. On the right hand side, the constant coefficient is 0. There is no constant coefficient. Then when you check the coefficient of x, you can see that on the left hand side, the coefficient of x is minus 2a. Okay, equal to, on the right hand side, it is 2. That means coefficient of x here is 2. So you can see that your a now will be equal to minus 1. Okay, if I substitute that into the first equation, I'm going to get minus 1 minus 2b equal to 0. Okay, so that means minus 2b is equal to 1. That means b is equal to minus 1 over 2. So we got a to be a to be minus 1, then b to be minus 1 over 2. Okay, and let's rub this off. So let's rewrite that. Our a is equal to minus 1, then our b is equal to minus 1 over 2. So that means that our particular solution yp, which we wrote as ax plus b, is going to be, your a is minus x, okay, plus your b. What is b here? Your b is minus half, okay, so minus half, which I can still write as minus x minus half. So we can write that somewhere. So that's our yp is equal to minus x, then minus half. Okay, so it means now that our total solution now, that means the combination of the two, the solution now is going to be yh plus yp, like we said. Now our YH, we got it to be C1 exponential minus 2x plus C2 exponential x. Now plus YP, what is YP? We just got YP now to be minus x. So let me rub this off. So we got YP now to be minus x, okay, then minus half, minus x minus half. This is beautiful. Now, but this is not all there is to this question. Remember, we are also given that y0 is equal to 0 and y prime 0 is equal to 1. Remember, this is y equal to this. And so how do we go about that? So y0 is equal to 0, meaning that if I substitute x to be 0, y will be 0. So let's do that. Let's substitute x to be 0. If we say let x be equal to 0, this is going to be c1 exponential 0 plus c2 exponential 0 minus 0 minus half, okay, equal to 0. Okay, so that means c1 plus c2 is equal to half. You know, that's the first thing I'm going to have. I can write it down somewhere. C1 plus c2 is equal to half. Then coming to y prime 0 is equal to 1. Let's do that quickly. So I want to rub this off. Just write it down. I rub this off. Okay. So we are given that y prime c. So what is y prime? Y prime means to differentiate this. So how do we differentiate this? This is going to give us minus 2 c1 exponential minus 2x. This is going to give us plus c2 exponential x. Differentiate minus x is minus 1, okay? So differentiating half is 0. Now if we substitute x to be 0 here, it's going to be minus 2c1 exponential 0, okay, plus c2 exponential 0, then minus 1. Remember, equal to 1 because we are given that y prime 0. Remember that y prime 0 is equal to 1. So that's 1 equal to this. Okay, so it means that if we collect like terms, we are going to get minus 2c1, okay, plus c2 is equal to 2. That's exactly what we are going to get. You can write that somewhere. Minus 2c1 plus c2 is equal to 2, which we can solve simultaneously. So let's bring them down to solve them simultaneously. We have c1 plus c2 to be equal to half. Then we have minus 2c1 plus c2 to be equal to 2. I think we can achieve that by subtracting. If we do that elimination method, c1 plus 2c1 minus minus, which is plus 2c1, is 3c1, okay, equal to half minus 2 will give us minus 3 over 2. Okay, so that means my c1 now is minus half. If c1 is minus half, what is c2? c2 is half minus c1, which is half minus half minus c1, which is half minus minus half, and that is equal to 1. So you can write that somewhere, that your c1 is equal to minus half and your c2 is equal to 1. This is beautiful. So that gives us our final answer. Remember, we got that y equal to c1 exponential minus 2x plus c2 exponential x, okay, minus x minus half. So now that we've gotten values for c1, c2, given those values, if we substitute that, we're going to get y equal to c1 is minus half. So minus half exponential minus 2x plus c2. c2 is 1, so we just write it as exponential x, then minus x minus half. This is the answer to that question. Man, quite interesting. Okay, so we are going to look at one more example. We have this. It says use the method of undetermined coefficient to solve the equation. Okay, that's what we have. 2y prime prime minus 4y prime minus 6y equal to 3 exponential x. Now remember, the first thing that we do is to write out the general solution. The general solution is going to be 2r squared minus 4r. You know, that's the operator, changing the operator to quadratic equation, then minus 6 all equal to 0. Yes, that's exactly what we should have. We can choose to divide through by 2 to get r squared minus 2r minus 3 is equal to 0. which we can factorize, is going to be r plus 1 and r minus 3 equal to 0. So that means r is equal to minus 1 and minus r equal to 3, minus 1 and 3. Or you can say that your r1 is minus 1 and your r2 is 3. So what does that mean? It means that the general solution here is equal to c1 exponential r1x plus c2 exponential r2x, which is equal to my c1 exponential, my r1 is minus 1, so minus x, plus c2 exponential, my r2 is 3, so 3x. Okay, so please do well to write that down somewhere. c1 exponential yh is c1 exponential minus x plus c2 exponential 3x. Okay, now that now leads us to find a particular solution. So how do we do that? Now, since my rx here is equal to 3 exponential 2x, what does that mean? It means that my particular solution yp, my yp is going to be a exponential 2x, where a is a constant. Okay, so with yp we can find y prime p, that's differentiate that, is going to give us 2a exponential 2x. Then we find y prime prime p. Okay, differentiate this, we are going to get 4a exponential 2x. Okay, so it's time to substitute it into this very equation. If we do that, we are going to get 2 times, instead of your, let me clean this up. Okay, so 2 times y prime prime p is 4a exponential 2x, then minus 4 times y prime, which is 2a exponential 2x. Okay, then minus 6 times y, your y is a exponential 2x, all is equal to, this guy here is 3 exponential 2x. Okay, let's rub off some things here. This is interesting. Okay, so this is what we have. So now, if we open up the bracket, we are going to get 8a exponential 2x, okay, minus 8a exponential 2x, okay, plus 6a exponential 2x, all equal to 3 exponential 2x. Okay, this cancels this, so we are left with this exponential 2x cancels exponential 2x. So what is your a? Your a is simply 1 over 2. Okay, so what does that mean? It means that since your a is 1 over 2, it means that your p is equal to 1 over 2 exponential 2x. So remember, our general solution y is equal to yh plus yp. So it's going to be equal to, what is your yh? Your yh you already got to be c1 exponential minus x plus c2 exponential 3x. Then plus, what is your yp? Your yp is half exponential 2x. So that's the final answer to that question. If you have any question, please just call me, let me know. Thank you.